Welcome to part 3 of 3 of Compression Spring Design, a PlanetSpring.com production. What you'll see in this video: how to measure active coils, OD, ID, free length, and wire diameter, a sample calculation with incorrect variables, a tutorial on how to fix the problems in the first design, a finished design achieving all 5 key objectives. Before we move to the compression spring calculator, we'll need to know how to calculate the number of active coils. Use this diagram to help you determine the number of active coils in your spring. Here is an example of counting active coils. We'll start at the second wire. Why? Because it's not a full turn until it makes a 360-degree coil. From there, we'll count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and a third of a coil. That's 15 and a third of a coil. From there, we're going to deduct 2 coils. Why? Because the first and last coil play no part in our active coils. We only want to concentrate on the coils with pitch, and therefore we will deduct 2 coils. So that will be 13.3 active coils. We'll also need to know how to measure outer diameter, free length, and wire diameter. Determining max solid height or coil bind height. Solid height is the stacked coil height, which is always less than your L2 value. For example, our L2 has a 2-inch loaded height. Our spring has a 3-inch free length, which means my solid height must be less than 2 inches or the spring will reach coil bind height before traveling to L2. Let's begin designing. Let's assume our environment is fresh water. For fresh water, I suggest you use stainless steel 302 as the material for your spring. Now let's move on to the compression spring calculator within PlanetSpring.com to create a spring design. Once you're at PlanetSpring.com, click on Spring Calculators. From there, you'll click on Compression Spring Calculator, and we're going to plug our first variable in. Let's try 0.065 wire diameter. The OD of our spring is 0.980. Our free length is 3 inches. And let's try 10 active coils. From there, click on the drop-down menu, and we're going to choose 302 stainless steel. Now we're going to look at our outputs, which are our answers, and let's take a look at variable number 1. We plugged in 0.065 wire diameter. Our outer diameter of spring is 0.980. Our free length is 3 inches. Our number of active coils is 10. Our material type stainless steel 302, and we hope to achieve a 10-pound rate, but we got 2.898 pounds per inch. To correct our design, we'll need to make changes in order to add more force to the spring. From this force chart, we can see that increasing the thickness of the wire diameter will increase the force. Right now, our solid height is 0.780 inches, and our L2 is 2 inches. This lets us know we have room to go up to 1.9 inches in solid height. Also remember that we want the OD to stay the same, so we will be decreasing our ID when we increase the wire size. Let's go back to our calculator and thicken our wire size. Let's go with 0.080, the OD the same, the free length 3 inches, and let's go with 11.5 active coils. We'll leave the material at stainless steel 302 and hit calculate. Let's go down and look at our answers. Number 1 is we increased the wire diameter to 0.080, the active coils to 11.5, and let's look at our spring constant. We're at 6.076 pounds per inch. Now how do we fix the problem? Let's change our wire diameter to 0.093. Change our number of active coils to 13.33. Remember, active coils are the coils that have space or pitch in between them. The first and last coils are dead coils and play no part in determining our spring constant, so only concentrate on active coils. Leave all other dimensions the same because of our limitations of space for the spring to fit in a hole and over a shaft in your device. Let's go back to our calculator and plug in the thicker wire diameter, 0.093. We'll leave our OD the same, 980, our free length of 3 inches, and let's increase the active coils to 13.331. Leave the material the same, it's stainless 302. Click calculate, and let's see our answers. Number 1, we've got 0.093 wire diameter, and we've got 13.3 active coils, and let's see, we've got a 10-pound spring constant. We have achieved our objective. We've achieved a good spring design by meeting all 5 key objectives. We've got a 980 OD to go into a 1-inch hole, a 790 ID to go over a 750 shaft, and a 3-inch free length. Para en medio. We calculated how much force we need at our loaded and working heights. L1 force of 5 pounds at 2.5 inch preloaded height, L2 force of 10 pounds at 2 inch working height. We determined the correct spring constant or spring rate. We achieved a 10-pound spring constant. We determined the correct spring material for our compression spring design. Our spring's environment is fresh water, so we chose 302 stainless steel. We optimized our spring design for maximum life and low stress. We increased our wire diameter to achieve our spring constant and increase our number of active coils to reduce our spring stress while not exceeding our solid height or coil bind height of 1.9 inch max. A good spring design equals optimized spring life. Thank you for watching Compression Spring Design, and for more helpful spring tips, go to planetspring.com.